This is problem 114 from the book. The problem reads, the strain energy function of a nonlinear hyperelastic material is given by this function, where A, B, and C are material constants and E is the strain tensor. Find the stress tensor S as a function of the strain tensor E implied by the strain energy function. So the key to this problem is equation 221 in the book. Write that up there. The equation is the partial of the strain energy function with respect to the strain tensor. And typically this would just be I and J. However, because we have a bunch of I's and J's in the equation here, we're going to switch the free indice to M and N. So when we start to go through and do this, we're going to have the first part here, so 1/2 A quantity, and here we have to use the chain rule because it's EII times EJJ. So the first is the derivative of the first, which is delta IM delta IN times the second, which is EJJ, plus the first, which is EII, times the derivative of the second, which is just, again, delta JM delta JN. So that's the first with A. And we continue on and we'll do the same thing for the rest of them. So if we just jot them out here, it's 1/2 B times the quantity delta IM delta JN EIJ plus, again, delta IM delta JN EIJ. And the last one's tricky because there's 3 of them, but it's just the same. It's still just a chain rule. So it's 1/3 C delta IM delta JN, and then, like I said, just times the second. So E J sub K E K sub I, and we just continue on doing the same thing for the rest of them. So it's delta JM delta K N, sorry about the sloppy handwriting here, I'm trying to get it so everyone can read everything, E I J E K I, and then the last is delta K M delta I N E I J second E J K. That's technically the answer, but we can clearly simplify this down some. So as we start to simplify it, this will equal, here the delta IM delta IN just becomes, have 1/2 A again. And once we simplify this down, that just becomes delta MN. So we put delta MN times, again, EJJ, EJJ, plus, here we have the J's repeated so that we can just simplify down to delta MN again times EII. So delta MN EII. Now we can do the next one, see what we can simplify there. Well, when we look at this one, it's 1/2 B times delta IM delta JN EII, which is the same thing. So we just move the 2 out front. That simplifies the 1/2 down to 1. So we're left with B times E M N. And that's all we have for the second line. For the final line, we can simplify that a little as well. So we're left with 1/3 C. This time, again, we can use the deltas to remove some of the summations that are implied. And how we do that is, so it becomes I with the I and the J with the J. So these simplify down to E N K E K M, and everyone can see how that's done because the J and the N are switched, so you get E N K, and then the I and the I, so then it becomes E K to the M because the I's go out. We do that through on the rest of them, and we're left with E I M E N, sorry, E N I plus E N J, E, J. We could still simplify this yet a little further. Obviously out front here it's delta Mn, delta M, and you can simplify the JJ and the EII, but we can move the delta out front. So we're left with 1/2 A delta M N quantity E JJ plus E II. Here we've already simplified this down as much as we could in this last step, so we're just left with there, we're B, E, M, N. The last step, we could actually do a simplification based on the fact that it's ENK, EKM. You see that the K is repeated. So what this will simplify down to, and I'm just going to make a little side note up here, so that ENK, EKM actually just becomes E squared, and you're left with N and M out here. So if everyone can kind of see how that's done, the K's are out, which is just E, and then N and M. So if you take a look at this equation here, we have the repeated K here. If you switch these two around, so it's really ENI, EIM, and here it's the same thing, ENJ, JM.